So number 3 on your study guide says a farmer has a field of 70 acres in which he plants potatoes and corn. The seed for potatoes costs $20 an acre. The seed for corn costs $60 an acre. The farmer has set aside $3,000 to spend on seed. The profit per acre of potatoes is $150 and the profit for corn is $50 an acre. Find the optimal solution for the farmer. So we have several units of measure here. Well, not several, a couple. We have acres, and then we also have cost per acre. So what I'm going to do is I'm going to organize this information in a table. So once I set up my table according to the information, I have potatoes and corn. They each have a different cost and they each have a different profit. And the farmer set aside $3,000. So the total cost would have to be less than or equal to $3,000. And then I have this information about 70 acres for potatoes and corn, and that really helps me figure out my variables. So if I make potatoes X and corn Y, then X and Y really represent the number of acres. And so that means that if I add X plus Y, the numbers of acres of potatoes and corn has to be less than or equal to 70. So the constraints for my problem will reflect that. 20x plus 60y is less than or equal to 3,000, represents my cost. And then x plus y is less than or equal to 70, represents the limit of the number of acres I can plant the potatoes and corn. And then also I have to keep in mind that x and y cannot be negative, so I have to include those constraints as well. So x has to be greater than or equal to 0, and y has to be greater than or equal to 0. My profit equation is going to be based on the profits that were given per type. And so I'm going to write that out as P of xy equals 150x plus 50y. So that's my constraints, the limit on the cost and the number of acres, and then my profits represented here. And now I'm going to graph the constraint. For my first constraint, it was easier just to find the intercepts because it was written in standard form. But for my second constraint, I converted it to slope-intercept because there were no coefficients for x and y, so it was really easy to move the x to the other side. And so I think for my scale, I'm going to count by tens. So for my first constraint, I just plotted the intercepts of 50 and 150, counting by 10. And then I used the slope and intercept for my second constraint. And then the third and fourth constraints are just the x and y axis. And so my feasible region is this region here, kind of in between the axes and the two lines. So now I have my vertices, the origin 0, 0, that y-intercept of 50, 0, the x-intercept of, 0, 50, and the x-intercept of 70, 0, and then that intersection where those two lines cross, it looks like it could be at 30, 40, but I need to plug it in to see if it's actually a solution. So is 30, 40 actually one of the vertices? So I'm going to plug it into each of my constraints to see if it's actually a solution. And once I do that, I see that it does equal 3,070. So that is the actual vertex there where they cross. And so I know that that is my fourth vertex to test into my profit function. So now what I'll do is plug each of those into the profit function to see what will give me the most profit. Once I plug in all my vertices, I see that the last combination, 6,500, honestly I thought that was going to be my solution, but it turned out to be where x is 70 and y is 0. So it says find the optimal solution, which would be 70 acres of potatoes and no acres of corn. Look, haha, when I named it with the variable y, it looks like corny. That's funny. Anyways, so the optimal solution will be just 70 acres of potatoes and for a profit of $10,500. And so that would be my final answer. So that's how you work through a linear programming problem.